Welcome back for this last video where we will see how to create new elements in your library. So here we have already quite a few elements, but let's imagine you're looking at a very specific system and none of the elements in the library allows you to model exactly what's happening in your physical system. And you want to create and develop a new element. How can you do that? Well, if you go to the element folder, you can create your element and store it here. So for example, the duct, and you see how to use the class definition and how to define the properties and so on. So let's say you have created a new duct that allows you to model new phenomenon that is not captured with the simple duct. So I have my new duct element, and here's the parameter. Let's say it's the length, numerical parameters, and let's say we also have I don't know, some porosity, and we also have some thermal conductivity, lambda, and whatever parameters you would like to have. So you put that in the properties, then you have to implement your duct to match the equation you derived. Then I have to change and be careful that my class has the same name as my file name, and I have and that's it. So let's say I have finished coding and implementing my equations. Now I want to add that in the library. So first, the library is locked to prevent spurious changes that you would do unintentionally. So you have to unlock the library. Now let's say it's the simplest solution is to copy paste one existing element. So you see that there is a link between this, or you see a chain here symbol, which means that there is a link from this element to the one we copied it from. So what you want to do is right click and disable the link. So it's disable, and then you want to right click again and you want to break the link. Now there is absolutely no link anymore between those two elements, and you can say it's my new duct. Okay, so now we want to add the new parameters in our mask. So what we do is we go to mask and edit mask. So here we have different tabs and we will go through all of them. So the first one is icon and ports, which is how your icon is looking. So you can have a block frame, visible or invisible. You can play with transparency, icon rotation, so you can rotate it or have it fixed. The last function, run initialization, you can have it off or on. When it's off, it means that your icon is always the same, no matter the parameters. And if you put it to on, it allows you to update the icon based on the parameters. Let me explain it with the flame example. Or with the, let me explain it with the area change example. If I go to the mask, edit mask, and I go to the parameters. So here it's on because I use one of the parameters, which is the area ratio, to change the icon appearance. So if it's greater than 1, it has to look like this step. So it's this part. If area ratio is greater than 1, then draw this. Now if I put it to 0.9 and apply, you see it has a different icon. It looks different. That's because if it's smaller than 1, it has to look like that. And if it's exactly equal to 1, then it looks like a straight duct with potentially a length, inertial length, and a zeta loss. So by using the run initialization on, it allows you to change the icon appearance based on one of the parameters that you provide, which is convenient for your icons to update and look nicely, and it's easier to interpret when you're building your model. So let's go back to the mask of our new ducts. And so here are the commands to plot. So you can either import a PNG file or you can plot it manually with the function patches and plots from MATLAB. So let's say, for example, we want to change the color here. We can just change the RGB code and you can change how it's looking. So a very simple commands, and you can plot basically any geometry you want. Then we have the parameter tab. So this is where we define how our parameter box is looking. So here are all the parameters we need to provide, and let's say I want to add, and they can be of different types. So you have edit, which is those type of cases where you put a number of brackets. You have checkboxes, which is exactly that. You check and uncheck your box. You have pop-up. Let's call that porosity. If we preview it, we can give different options in the pop-up. So pop-up would look like that. I allow you only to choose between different functions. Between different values, can be text or numerical values. Then you have radio buttons, sliders. You have all types of buttons that you can use. If you want more info, you can read the Simulink and MATLAB documentation. Then you can use group and tabs and collapsible panel to organize it. For example, here I have it for numerical parameters. I use a collapsible panel for simplicity. And here you can again also put some condition on how the block parameter has to appear depending on the parameters you select. Let me explain that with the flame element. For example, you see that if I select the constant CP, I have only one option, which is the temperature ratio. But if I select constant CP, I can put the area ratio. Constant CP with Mach number, I can put the area ratio, and then if I put realistic fluid, I can also put the fuel, and I can even put the lower heating value and the C atoms. How do you do that? You can say, depending, so for example, depending on what I choose here, I want some parameters to be hidden. So here, that's my set of equations. It's a pop-up type. So here I edited the different types you can choose from. And then you have a callback function. So the callback function is just to say conditions on, hey, look at the values of my mask, and if in my pop-up, if in my set of equation it's selected to realistic, then hide some parameters and show others. Or if it's selected to constant CP, then I want you to hide this one and this one and this one and this one and show only the others. So the parameter order is just the parameter order you have here from 1 to 11. So you can also have your mask that change with the parameters you select. So again, we go back to the flame. Depending on what I choose here, it display different parameter options. So you can also all control that with the callback functions. Then you have initialization, which is the names of your parameters. So those names have to match your class definition name. So if I go back to the my new duct element, I added the porosity and lambda. So here I added the porosity, and let's say lambda will be a slider. So lambda will be a slider, so that would be looking like that, for example. So that's all type of options you can choose. Obviously this is not the way you would go for those types of parameters, but that shows you what you can choose. Now you go to initialization and you see that all the parameters you had in your parameters and dialog box appear here in your initialization variables. So now you need to change the names here to match exactly what is in your class definition. So L for the length is there. And here we would need to change that to call it porosity, and we would need to change that to call it lambda. If the names are not matching, then you will have a problem when reading the network model you build. And then you can have use the last tab to do some documentation to describe exactly what your element is doing. So, and when you're done, you simply apply, close it, and there you have it, your new element with your new parameters that do exactly what you want to do. Then you can lock the library to prevent any changes, and that's it. And if you're not satisfied, then you can again update your mask to have it look like exactly the way you want. You can change your parameters, and that's how you create a new element for your library. Obviously, it's all based on Simulink, so I do not have time here to cover everything, but you can find a lot of documentation on how to build mask and how to use function and callback functions and so on in the MATLAB online documentation. Here I just gave you a slight overview on what would be the steps if you would like to do that for your cases. Thank you for following this series of videos. I hope you enjoyed it and that it helped you building your networks. If you have any problem, or if you want to suggest improvements, or if you have new ideas, feel free to reach out to us at TFD Group. We will be happy to exchange on the topic. And we want to thank you also for your interest in our research and tools, and we hope that you will appreciate TX.